Let's talk about one of the biggest, most mind-bending ideas in all of science, the multiverse. And no, this isn't just for comic books and movies anymore. This is a serious idea, a prediction that kind of just pops out of our deepest theories about the cosmos. So here's the question. Are we living in just one universe, or are we part of something, well, infinitely bigger? The journey to figure that out starts with a really specific and very strange puzzle. So, our whole investigation really kicks off with this deep mystery. When you look at the fundamental rules of nature, things like how strong gravity is or the mass of an electron, you find they are just perfectly balanced. It's almost as if our universe was designed with one thing in mind: creating stars, galaxies, and, well, us. Scientists have a name for this. They call it the fine-tuning problem, and it is a huge puzzle. The sources we looked at point out that if you just nudge these values, even by a tiny, tiny fraction, the results would be catastrophic. Make the nuclear force a little bit stronger, and bam, all the hydrogen in the Big Bang would have cooked into helium. No fuel for stars, no water, nothing. A little weaker, you wouldn't get any elements heavier than hydrogen at all. So you have to ask, how on earth did we get so lucky?
To try and answer that, physicists have been following a trail of clues, and each one leads to an even bigger picture of reality. The very first clue suggests that the answer might just be a matter of sheer scale. This is what you might call the simplest type of multiverse. It's sometimes called the quilted multiverse. The idea is pretty straightforward. Space is infinite. So you know that huge 93 billion light-year sphere of space we can see, our observable universe? That's just one little patch on an infinitely massive quilt. Way, way beyond what we can see, there are other patches, other cosmic horizons, where the exact same laws of physics are playing out, just with different starting conditions.
And you know what's really interesting is how plausible this idea is. There's no law of physics that says space should just stop right at the edge of our vision. As this quote gets at, a lot of cosmologists basically think that if you could magically travel past our cosmic horizon, you just see more of the same. More stars, more galaxies, on and on, forever. We can never prove it, of course, but it's a pretty natural outcome if you think the universe is infinite. Okay, but what if those other universes weren't just more of the same? What if they were playing by a completely different set of rules? Let's grab our next clue because this is where things start to get really wild. So our best theory for the super early universe is something called cosmic inflation, this tiny fraction of a second where space just exploded in size. A version of that theory, called eternal inflation, says that process never really stopped everywhere. So picture space-time as a giant, ever-expanding block of cheese. Every now and then, in a random spot, the expansion slows down and a hole forms. That's a pocket universe, like ours. But the cheese itself, it just keeps on growing, making more room for more holes to pop into existence. And right there, that gives us a potential solution to our fine-tuning mystery. Each one of those bubble universes could cool down with slightly different laws of physics. Now, most of them would be duds, total, empty, lifeless voids. But in a huge cosmic foam of billions upon billions of these bubbles, it's not so surprising that at least one, ours, would happen to have just the right settings for life. We exist here because this is one of the bubbles where we could exist. And then string theory comes along and adds another absolutely mind-boggling layer. It predicts this massive landscape of possible physical laws, maybe as many as 10 to the 500th power. I mean, that's a 1 with 500 zeros. The diagram you see here shows it as an energy landscape. Think of it like a huge mountain range where every single valley is a stable set of physical laws. Eternal inflation is like a ball rolling across this landscape, dropping into different valleys and kicking off new bubble universes, each one with its own unique physics.
Okay, so we've gone from distant patches of our own universe to a cosmic foam of bubble universes with different physics. But this final clue, this one takes us to the deepest, most fundamental, and most abstract level of reality you can imagine. This is the ultimate multiverse, and it's an idea from cosmologist Max Tegmark. The hypothesis is, well, it's profound. The idea is that our physical world is a mathematical structure. Not just that it can be described by math, but that it's literally made of math. And if that's true, then any mathematical structure that is self-consistent has to exist as its own separate physical reality. So what does that really mean? It means reality isn't just limited to the kind of physics we're used to. It could include universes based on totally different mathematical rules, maybe with different numbers of dimensions, different kinds of particles, laws that we literally cannot even imagine.
Our entire universe is just one book in a vast, infinite library of every possible mathematical form. Now, I know these ideas are thrilling, but they also come with some enormous scientific headaches. The multiverse isn't just an accepted fact, not by a long shot. It really pushes up against the very definition of what science is. So let's look at the toughest criticisms. This is the big one, falsifiability, right? The whole point of science is that you make predictions you can actually test. But if we can never, ever interact with these other universes, how could we possibly prove or disprove they exist? A lot of critics say this is where the multiverse stops being physics and wanders into the realm of metaphysics, or maybe even just philosophy.
But there's another problem, one that's a bit more subtle but drives physicists crazy. If you have an infinite number of universes, and so an infinite number of people observing things, how can you make any meaningful predictions about what we should expect to see? This whole puzzle is called the measure problem.
Let me show you what I mean with a simple example. Check this out. If I ask you, what fraction of all whole numbers are odd? Well, your answer completely depends on how I count them. If you look at the first row, just counting normally, 1, 2, 3, 4, the answer gets closer and closer to 50%. But look at the second row. Here, I'm listing 2 odd numbers for every 1 even number. Now, the answer approaches 66%. And here's the kicker. It's the exact same infinite set of numbers. And that, right there, is the measure problem in a nutshell. It's the exact same challenge cosmologists are up against. If you want to predict what a typical observer in the multiverse should see, you have to figure out a non-arbitrary way to count an infinite number of possibilities. And right now, different ways of counting give you wildly different predictions, and nobody can agree on which one is the right one. So, after that whole journey through cosmic quilts and bubble foams and pure mathematical realities, where does this leave us? Let's just pull it all together and sum up what we've found. First, remember that the multiverse isn't one single theory. It's a collection of different ideas, some more plausible than others. Its main job, really, is to offer a possible solution to that whole fine-tuning mystery. And it's not an idea that was just invented for fun. It seems to pop out of the math of our best theories, like inflation and string theory. But, and this is crucial, it forces us to ask some really tough questions about the limits of science itself. You know, maybe the best way to think about the whole thing comes from a great analogy by physicist Andre Lind. He says the fine-tuning problem is like asking, why was I born in Moscow of all places? You don't question it. But, he says, if you were born in Moscow and you discovered that everyone there speaks Chinese, well then you'd be really surprised, and you'd start looking for an explanation. Our fine-tuned universe is like that Moscow where everyone speaks Chinese. It's so specific, it kind of demands a bigger context, and the multiverse is one possible answer. In the end, the multiverse isn't just a question for science, it's a question for philosophy. It forces us to rethink our place in everything. Maybe we're not the center of the universe. Maybe we're not even the center of our own reality. So I'll just leave you with this to chew on. If our entire existence is just one possibility out of a literal infinity of others, what does that really tell us about what it means to be real?